All right. So, welcome everyone to this new course called CSF 425 Deep Learning. I'm sure you had the chance to meet your instructor, Dr. Kamlesh Tiwari. I'm Palash Agrawal, and I'm going to be your TA for this semester. I'm going to be designing and taking your lab sessions, designing a few research components, and also helping you with theoretical and code related doubts and issues. So let me just tell you a little bit about myself. I'm a final year Triple E student here in the Pilani campus. For any one of you who had taken the machine learning course last semester, I was also the TA for that course, also taken by Dr. Kamlesh Tiwari. So this semester, I decided to be the TA for this course, which is being taken for the first time in BITS Pilani. So I'm really excited to make this course a wonderful experience, a wonderful learning experience for me as well as for you. Um, so I'm going to be recording this session as a sort of prerequisite to all the upcoming lab sessions. This lab session is what I'm going to be calling Lab 00. It's an optional lab session. It's for those who don't know Python or just want to brush up their Python skills or just programming skills in general. If you do know Python, you can feel free to just skip uh, this recorded lab session and just directly get started with Lab 1, which is going to be held this Saturday on the 28th of August. So, in this lab session, we're going to be covering a few basics of Python, a few basics of object-oriented programming in Python, and also introduce ourselves to what deep learning is from a practical perspective. So the point of these practical sessions that I'm going to be taking is to introduce you to the practical side of deep learning, whereas the lectures are meant for the theoretical side of deep learning. And we sort of have this vision for this course that we want to make this a really modern course, a really 2021 oriented course, not something from 2010, 2015, and whatnot. So uh, let's actually get started with this. I'm really excited. So, why Python? So, Python is the go to language for all machine learning and data sciences as of today. It's hard to say what it's going to be in the coming few years, but it's very important that you are up to date with the language of machine learning and data sciences. And of course, you would have known till now, deep learning is only a subset of machine learning. So of course, Python becomes the language of deep learning as well. So why has Python become so dominant in this space? It was always not so. I mean, the machine learning has been done in a lot of different languages. There was a time when it was done in R. Then came Cafe. It was also done in Java, C++. But then slowly Python just took over everything, and it has done so for a few particular reasons. Let me just walk you through a few reasons as such. So, the main reason why Python is so famous is probably because of its very dynamic nature. Now, what do I mean by very dynamic nature? It's uh, it's just very oriented to actually change your memories and your pointers depending on whatever your use case is. So and that's what we really need in something like deep learning and machine learning, where you need data structures and you're constantly iterating through different things, and you need to throw away something, you need to bring on something new and stuff like that. So it helps, the dynamic nature of that helps, as opposed to something like C++, in which you probably don't have the ability to change something at different levels of the API. You have to go to the source code and do something to do anything, honestly. The language is also very intuitive, which one does not have to learn very unnecessary syntax like semicolons and like you have to take care of I don't know, brackets and whatnot. So this has also led to the popularity of Python in the community and in the coding world in general, because I mean it's just an easier language to learn for a beginner. That's not particularly the case in India. And in India, we still teach C++ as a first language, but I don't really understand why. Um, Also, another reason for its popularity is the large community. I mean, once the community becomes large enough, it's much more likely that, I mean, the platforms and the libraries that you have in that language are going to be growing very fast. It also means that if you have a bug, the community is going to come forward and going to help you with that bug. So it's going to be solved very fast. It also means that there's much more support for beginners and for professionals as well, which is a reason enough for someone to actually be attracted to this community. A large community has actually resulted in Python being like the only self-sufficient language to exist today, especially in the data sciences world, in the data world. Um, and it has essentially wiped out all of its competition: R, Cafe, Java, C, whatnot. To give you an insight about the reach of Python in the programming world, um, I, I I can give you a few examples of a lot of frameworks and APIs being developed on top of Python. Uh, a framework is essentially just a library which basically writes down a lot of your basic code which you're going to be using very often, so that you don't have to rewrite it from scratch again and again. So now, what essentially that means is that you can. It's very easier for it's easier for beginners to actually get started with it. Deep learning has actually come to a point where there are methods to actually write a world-class state-of-the-art model in just like 5 lines of code or 6 lines of code or something. So that's amazing. Um, and uh, by state-of-the-art, I just don't mean like one type of state of the art. I can show you, and we're going to see in this particular course, that you can actually build systems like self-driving cars, and I don't know, facial recognition systems, and speech text generators, and really amazing stuff with those few lines of code. So that's really amazing. Um, so let's actually get started with it. I think we'll walk through what Python is, how to use it, a few basic syntaxes and whatnot. So let's actually start by describing what we're going to be using as our environment for writing our Python code throughout our journey of this course. Um, we are going to be using something known as a Jupyter notebook. And the way you spell Jupyter is Jupyter notebooks. Uh, and not and I'm going to be telling you what essentially Jupyter notebooks are, but first let's actually get started with how do you actually create one. So Jupyter is an open source uh, IDE which is distributed by Anaconda. You can actually download it on your laptops, but I don't recommend doing that. It's very cumbersome. So let's actually just do it on the cloud. So for that, we're actually going to be using a free version which is provided by Google. It's called Google Colab. So let's actually get started and let me show you how do you create one. And it'll become more and more intuitive and much more clearer as we proceed. So, all right. So what I want you to do is go to your Google Drive. Go to You must have made some folder. Go to any appropriate folder where you want to work this lab through. And on the top left corner, you're going to see this button called New. Press that, go to More, and you'll probably see something known as Google Collaboratory. If you don't see one, what you need to do is go here, go to Connect More Apps, search for Google Collaboratory, spelled like this. Click on it, install it in your Google Drive, and then just go ahead and make it. So I'm just gonna click on this, and it's gonna open something which looks like this. Right. So you may or may not have seen this. If you are familiar with some sort of Python or machine learning in general, I'm very sure you must have seen something like this. So the first thing that I'm going to do is just going to rename this. It's just for me. I'm just going to name it Lab 0, whatever. So what you can do is basically follow me. uh, I'm going to be writing pieces of code, and you can just follow me wherever you think that you don't understand anything. Pause it, go back. If you still don't understand it, try googling it. Try to see different things. So, all right. So this is called a Jupyter notebook. Uh, Collab is the Google's version of a Jupyter notebook. It's essentially the same. So here you can actually write Python code or and like a code in a lot of different languages very efficiently. Uh, it's quite convenient for data scientists and machine learning engineers to just and data scientists in general to use to use an environment like this, which is so interactive, which is so dynamic. And here's what I mean by that. I'm going to be writing my code over here. I'm just going to write a simple piece of code, print hello world, which is probably like the most famous line of code for beginners. I mean, first line of code that most beginners write. And I'm going to run this. So it runs your code over here. I can also add text over here, which I'm going to say, hey, this is the zeroth lab in the deep learning course. Yeah, you can add that. You can also add images in over here. You can add videos. You can add GIFs. You can add bulleted points over here. You can indent your. You can insert links and whatnot. I mean, it's a very dynamic environment. It's like everything that you need to visualize your to actually run your model, including documentations, including code, and including any other information, any other visualization methods, everything in one place, which makes it the best thing for probably for data scientists in general. How is it different from other IDEs that you must have used before, like VS Code or like, I don't know, Turbo C++, and I don't know, the Linux Vim used to write code in Vim in the first year CP course, if you remember. I mean, you can't add all this stuff, text and like like comments and stuff like that in those editors. So, which is why Jupyter Notebooks is the thing that we're going to use. It's much more intuitive for beginners and quite efficient for professionals as well. Um, if you run across some bug in your code, you don't actually have to, like rewrite or rerun the entire code. You can simply fix the bug and just run the only that one line of code which has that bug. So in a text editor, you need to compile and run the code again and again. Each time you have an error, that takes a lot of time. So it's not recommended. So uh, I'm gonna show you, demonstrate how do you actually write code. So this gray colored box over here, which you see, in which I've written this print hello world, is called a cell. So I'm just gonna write it over here. This is a cell. By the way, how do I write it? I'm just gonna go and at the top of, let's say, any cell, you're gonna see two options, either code or text. When I enter text, I'm gonna get something like this. And when I want to execute it, when I've written this is a cell, I'm just gonna go press Shift Enter. So you can do that, and it's gonna come to the next line. It's gonna create a new line of code. By default, when you create a new line of code, it's gonna be code, not text. All right. Now let me just delete this. So here we are, and we need to start writing from here. So this is a cell, uh, and what you need to do is let's actually start writing some piece of code. Uh, so I'm going to start with something very basic like print hello world. You can follow me. It's pretty nice. And to run it, what I need to do is I'm going to press Shift plus Enter. So what Shift plus Enter does is that it's going to run that code and come to the next line of code. If there is no next line of code, it's going to create one new line of code. So I'm going to press hello world. It's gonna execute. It printed hello world for me, and yeah, that's pretty. I've executed a piece of code. I can actually go back to it, run it again and again, and yeah. So essentially, you're not actually running the entire notebook. You're just running that one line of code. So imagine when you're going to have like 10 cells of code, you can actually essentially run one after the other and not in particularly necessary order. That's just one very good thing about Jupyter notebooks. All right. So um, before I start, I want to give a disclaimer about this this particular session, which is that we are not going to be teaching you everything in Python. No language actually can be taught end to end from scratch to a level of mastery to anyone. You have to learn it by practice. You make a lot of errors, and that's completely fine, and you learn along the journey. So I'm just only going to be teaching you something to get you started with Python, and then it's all upon yourself how much you want to devote your time, and how much you're dedicated to learn this language. Uh, i don't really believe in the fact that, I mean, everything has to be taught in that course and you have to score marks. I mean, marks are secondary, which is why I also recommend, I mean, it's completely fine to use Google. You can just, whenever you come across an error, just Google it. Just don't Google it in your mid semesters and your comprehensive exams. But when you're in a lab, why not? I mean, like, there's no restriction to Google stuff. That's what Google is meant for. I mean, no one expects you to learn everything in the real world. So just Google whenever you have an issue, and yeah, you're gonna get better over time. And we are just gonna get you started with Python, but like throughout this course, whenever we're gonna come across a new topic, I'm gonna introduce you to it. I'm gonna make sure that you understand it really well. And again, don't be afraid to make mistakes. And it's not my job to teach you Python. It's your own job, your own responsibility to learn it as well. All right. So let's actually get started with Python. So I'm sure most of you have some experience with coding. If you're anyone who's in university, usually has a computer programming course in the first year. You may or may not have learned Python, but I mean, even if you've learned any programming language, most of the concepts remain the same. Even if you don't have any programming knowledge or you think you've forgotten your programming skills, that's okay. You can either brush it up or you can learn it along the journey. It's probably going to take, I don't know, some more time, but it's probably worth it. All right, so let's actually start with something known as variables. Right. So, uh, variable is essentially a container which is going to contain some value. For example, I mean, you might need to store the values of, say, the name of a person or the age of a person, which is an integer, or you want to, I don't know, reference to some other container which contains some other value. So you need some measurement or you need some mechanism to actually store these values in your memory. Otherwise, you just, I mean, as soon as you're gonna come across them, you're gonna just forget them, or you're not gonna have access to them anymore. So uh, there is no restriction as to what type of variable may have in Python, unlike some other languages like C++. Like, for example, if you declare a variable as an integer type, you can only store an integer in it. There is no such restriction in Python. And so that is what actually gives a lot of sensitivity. So I'm just gonna start, and let's actually write down some examples. So I'm just gonna name my variable, let's say my variable, and I'm gonna assign it the value of my name, and you can assign your names as well. And then what I'm gonna do is that I can simply do print my variable, and now because my variable contains the value Palash, I would expect that it returns the value Palash. So I'm just gonna go shift plus enter. Or here's another trick. If you actually want to stay on that line of code and not actually jump to the next line of code, you can do CTRL plus enter instead. So I'm going to press CTRL plus enter. And yes, as expected, I get the value Palash. Uh, Let me introduce you to one really cool thing in Jupyter Notebooks. You don't necessarily have to write print. If you just write my variable over here, so my variable is actually going to show whatever stored in my variable. You don't necessarily have to use the print statement. So I get the value Palash as well. All right. So okay. Now again, you know that my variable as of now has a value of a string. A string is like, alphanumeric characters that you store within quotes or single quotes or double quotes, whatever, doesn't matter. I'm so as of now it's a string, but I can actually change it to something else. I can add my age. So I'm 21 right now. I'm gonna add the value 21, and I'm gonna run this code using ctrl plus enter, and I'm gonna get 21 as my answer. So you see how variables are flexible in Python. All right. A few things that you must keep in mind is how do you actually uh, how do you name your variables. You can't just name your variable anything, though there is a lot of flexibility, but there are some limits to this. So right now, I need to come to the next line of code. I don't really want to move my mouse and then press on code. So what I'm going to do is I'm just going to go to this line of code, and I'm going to do shift plus enter, so it's automatically going to come to the next line. Right. So the first thing that you need to keep in mind is that mm, variables are case sensitive, meaning that my variable, which has a value, let's say 21 right now, is not the same as my variable with a capital M. I'm going to run this, and it's going to probably give me an error because I've not defined this variable yet. And yes, that is true. Name, my variable is not defined. So you need to keep that in mind. Um, the name of a variable cannot start with a number. So I can I've just started this with a number, and I'm gonna assign it some value. I don't know my name. It's probably gonna give me an error as well. That's invalid syntax, meaning that I cannot actually do that. Another thing is that it cannot start with any uh, uh, any special character except for an underscore. So if I do full stop over here, that's not allowed. That's invalid syntax. But underscore my variable is probably allowed. Yes, it is. So you can actually find these lists in. Uh, you can actually find these syntaxes in this uh, link over here, which I'm gonna put somewhere. And I'm gonna leave the access to this notebook, so you can actually refer to this anytime. So this is the list of Python list of syntax for Python um, variable naming. All right. Right. Um, let's move ahead. So this is what a variable is, and let's actually move ahead. So we have now defined how variables can be defined. So what are different types of values can a variable contain? So we saw two of them. We saw a number and a string. So for example, my variable was 21. That was allowed. You can add a string. That was allowed. You can also add booleans, meaning like it's something true or false. You can actually do that. So if you write capital T R U E, you don't write. Make sure that T is capital and true. It's a boolean value, right or wrong, positive or negative. So that's allowed. Of course, the opposite of true is false. So that is also boolean. Variables can store that. Variables can also store different types of numbers. So this is an integer. 21.0 is a floating number, right? Yeah, so it can store all these different kinds of values. It can also store something known as none. None basically means nothing. It's not a data type of any type. It's just a placeholder for in the memory. It doesn't do anything. So yeah, right. Uh, it's probably gonna be it's gonna allow me to do that. All right. So let's actually explore all these different data types that I've introduce you over here. So I'm just gonna be, so this section is on data types, by the way, in Python, right? So, so what are the different data types that we have over here? It's uh, print one, for example, that's an integer. Print 1.0, that's a float. Unless it doesn't give me an error, that means it's a valid data type. So I'm just going to write it over here. This is an integer. This is a float. I don't know. I can actually also do arithmetics over here. So 1 plus 5. Um, I can do shift plus enter. It's going to give me answer 6. Integer plus integer is always an integer. Float plus float is a float. Integer plus float is a float. Make sure of that. So if I do 1, which is an integer, plus 5.0, and here's the cool thing in Python that you don't, if you have like leading zeros, you can actually remove all leading zeros. Plus it's like 5.09 something in which you actually absolutely need to write 09. Actually don't need to write that, and 5 dot is essentially the same as 5.0. That's going to give me the answer of 6.0. So this is known as something known as typecasting, and yeah, you can look it up on Google if you want to. But just remember this fact that a number, an integer plus float is a float. You can have uh, strings as a valid data type. So this is a string. String plus string. Basically, my full name is, by the way, Palash Agrawal. So I'm just going to go Palash plus Agrawal. Uh, Addition of two strings basically means concatenation, meaning it's just gonna join them together. And you can see that this happens over here, and it's gonna concatenate those both. You cannot add a string with an integer with a number, because I mean, like, it doesn't even make sense, right? So plus one, what is it? What do you think it's gonna give you? It's gonna give you an error. Yeah, yeah. I'm just gonna write here. This is going to give you an error. Right. And what all can you do with numbers? So I have one. Here I've done addition. You can actually do subtraction as well. So now, if I press Shift Enter over here, it's going to go to the next string, which is this plus hashtag string, which I don't want. I want to insert a new line of code. So when you want to do that, when you want to insert a line of code below a piece of code, what you need to do is first press escape, because otherwise if you press B over here or you press anything over here right now, it's going to basically type. So press escape, so the cursor is going to go, and press B. It's going to create a new line of code just below that. If you want to create a line of code above that, you can press A, but first escape. So I'm going to do escape and A, and inserted a line of code above that line of code. 1 minus 5, that's valid, right? 1, sorry, 10 star 5, this multiplication is given by star, that's valid. I'm going to add in a few lines of code. Division, 10 divided by 5, or that's actually 10 divided by 6, is going to give you some number, that's valid. Now, by default, division is floating division, meaning like it's going to give you the quotient as well as the remainder in terms of its fractional value. If you only want the integer, you can just do a double slash, which is something which you might have seen in C++. When you divide by default, you can only get the integral value, because the placeholder only contains, it can only handle integers, it cannot handle floating points. But since Python doesn't have that restriction, you can actually get floating points as the answer. Like integer divided by integer can give you a floating point. If you strictly want it to be an integral division, meaning it will only give you the quotient, you can do 10 divided by 6. So 2 double slashes. And it's going to give you 1, which is basically the integral part of this answer. What else? Power. So exponential is given by double star. So 10 star star 2 basically means 10 squared. It's going to give you the answer 100. That's okay. What else? Yeah, then you have some Boolean operators. Oh, sorry, some bitwise operators, which I mean you don't need to worry about for as of now. All right. So these are all the different types of data that you can do. Um, that you actually can use in Python. Of course, then we also saw Booleans, so true and false. Are This is a Boolean data type, right? Uh, right. Yeah, that's pretty much it. And then you have this none. So none is also a data type. And you can actually see what type it is. So whenever you want to see the type of a variable, you can just do type, and in brackets you're going to put in the variable name or the value itself. And so you're going to see that it's actually an entire different data type of its own. It's called the none type. And similarly, if I were to do it over here, you can do, so you're going to get I don't know, bool. So bool stands for boolean. All right. Let's actually uh, go with the next type of let's actually go to the next section. And right now we're going to be doing talking about lists. All right. Right. um right. So what are lists? Lists are probably like one of the most frequently used concepts and data structures in Python, and I think in most other languages as well. It's basically a collection of values. So a variable that we saw earlier could contain one value, right? What if you want to store 10 different items together, 10 different values together, 10 different variables together? So this is where the list comes in handy. So a list is represented by square brackets. So I'm just going to go my list is equal to square bracket, and this is an empty list as of now. I can basically add in values something like, I don't know, 10, 20, 30, 40, 50. And let's actually try to print it. And I'm going to do shift plus enter and see. This is a valid list. You can actually do, let's see what type, data type my list is. It's actually called list. List is a data type. It's a data structure. All right. So make sure that you don't actually name your list uh, as list. I mean, like list equals this. This is not valid. Right. Yeah, it's gonna run, but it's gonna give you an error later on because list is actually a reserved keyword in Python. List actually refers to list. So if you're gonna reassign the value of list to some number or to some data structure, it's not going to be able to reference to the original definition of list. So make sure you don't do that. Um, So I've actually run this. Now that's going to give me an error later on. What I'm going to do is that since I've messed up now, right now, I need to restart my runtime so that it's gonna, just reset everything to the original values. So what I'm gonna do is I'm gonna first delete this. Go to runtime over here and restart and run all. Yeah, why not? Okay. So it's restarting right now. Over here, you can see it's initializing, and yeah, everything's going to be run sequentially. Yeah, this was an error, so I'm just gonna. Oh, okay. Let's talk about this thing over here. Hashtag. This is going to give you an error. This is a comment. It's not going to be run by Python compiler. So over here as well, you saw. So Palash is going to be executed, but this hash string is not going to be executed because anything that starts with a hash is a comment. Just pretty similar to C++, where you have like where you use double slash, like double slash to write this is a comment, right? Right. Um, whenever so this is going to give you an error again and again, Palash plus one, because it's an invalid operation in Python. So for that, what you need to do is that I'm going to comment it, which means it's not going to be run by the Python compiler. Whenever you want to comment or uncomment anything, all you need to do is that go to the line of code and do ctrl plus slash, the one on the question, the button with the question mark and the slashes. I don't know what that is. Forward slash. I don't know. So ctrl plus slash is gonna uncomment it, and I'm gonna press it again. It's gonna go. It's gonna become commented again. So you can see that I can actually do that. Right. If you want to uncomment or comment multiple lines at once, simply select all the lines that you want to do and go ctrl slash ctrl slash, and you can comment or uncomment it. Right. Um. Yeah. Where was I? All right. Let's continue. Yeah, this was running as usual. Just keep on pressing ctrl plus enter, ctrl plus enter. All right. So now let's actually talk about something known as indexing. Indexing, which basically means how do you access values in a particular list? Because I mean, what if you want to access this particular value called 30? How do you access that? So you use that using something known as indices. And indices are simply numbers that are assigned to each of these values sequentially. So this 10 over here is assigned the index of 0. 20 is assigned 1. Uh, 30 is assigned 40 is assigned 3, and 50 is going to be assigned 4. So indexes in lists go from 0 to n minus 1, where n is the length of the list. The length of the list is 5 over here. Whenever you actually want to find out the length of a list, you can simply do len mylist. Len is a like defined function in Python. So it's going to give me the value 5. So I'm going to go from 0 to 4 to index all these different values. And when to index something, all you need to do is that write the variable name and put a square bracket in front of it with the index number. So my list, and if I'm going to be putting the index 0, I can assume that it's going to return me the value at the 0th index, which, as I just told you, would be 10. I would expect it to be 10. Does it work? Yes, it does. 1, yeah, I'm gonna get 20, 30, 40, 50, and then if I try to go beyond that, it's gonna give me an error. So this is gonna give you an error. Yeah, list index out of range, because the range of the indexes should be from 0 to n minus 1. I'm just gonna change it to some number. All right. So, all right. So this is indexing basically. Let's actually also talk about something known as slicing. Slicing basically means that instead of accessing one value, you access like a particular section of that list. So what if I want numbers from 20 to 40, like all together, and I want to throw away 10 and 50? So I'm just going to do sliced list is equal to list, sorry, my list. And see, I used to index one, I don't know, I want basically the indexes 1, 2, and 3, right? Because that 20, 30, and 40 are basically 1, 2, and 3 indices. I'm sorry. So what you do over here is that you use the following syntax. So I want to start from 1. So the starting number will be 1. And then I'm going to do a colon. Then the next number will be, what index do I want? I want it till 4. But then here's something weird about Python. This is actually, sorry, not 4. I'm sorry. The index number 3, right? So index number 3, 1, 2, 3 is going to give me some values. Oh, I need to print it as well. Yeah. So, but it actually doesn't give me 20, 30, 40. It only gives me 20 and 30. So here's a weird thing in Python. When you slice a list, it's actually, and when you say, uh, my list A to B, given that A and B lie in that range of indexes 0 to n minus 1, it's actually going to give you A to B minus 1 and not B. That's a weird thing. That is why if you want indexes A through B, you're actually going to have to write my list A to B plus 1. I get this is a slightly difficult concept, and so you need to revise this again and again. Probably throughout this week, it's going to help you the more longer you try to spend time with it. So this is actually going to give you value A through B, right? So So what I'm going to do now is let's actually rewrite this code. Since I wanted 20, 30, and 40, which is indexes 1, 2, and 3, I'm going to have to do 1 colon 4 and not 3. So when I do 1 colon 4, it's going to start with 1, but it's going to end at 3. That is 4 minus 1. So that's what I'm going to do over here. My list 1, 2, 4. And let's actually print it now. And yes, it gives us what we expect. Uh, let's actually do some variants of slicing as well. So now I'm gonna rewrite this slice list is equal to what if I actually want all the values from a particular list. For example, I want to start from 20 and whatever lies ahead of 20. So I shouldn't necessarily have to do like since okay, indexes go from 0 through 4. I want to start from 1, so I'm going to 1 colon, and since the last index is going to be 4, 4 plus 1, 5. I'm not 1 is to 5. I mean, like I mean, you shouldn't have to do that because like you already have one particular information that I don't want any till any particular index. That particular index that I want my number still is the end of the list. So there should be some internal method that actually says that well, I'm just going to tell you that I want till the end of the list. Python should figure it out for me. So what that is simply my list. I need to start from 1, and I'm going to leave the other index that is B, which I showed over here. I'm going to leave it empty. So this is actually going to get all the values from index 1 to the end. Sorry. Yeah, let's print it. Yeah, 20, 30, 40, 50. What if you want all the particular indexes still a particular index? So for example, what if I want all the values 40 and before that? So 10, 20, 30, 40. It's just the reverse of that. You can actually figure out the pattern by yourself. I'm just going to do it anyways. Right. So I need till index what? Of course, the first index is going to be left empty because that is the way I'm going to tell it that me everything before a particular index. And the second index now is again, since I want it till index what? 0, 1, 2, 3. I want it till index 3. 40 is index 3. But again, if I'm going to do till index 3, it's only going to give me till index 2. So I'm going to have to do 4 over here. That's 3 plus 1. And let me actually just print it. Yeah, 20, 30, 20, 30, and 40. That's exactly what we wanted. So, right. If you actually have trouble understanding this, uh, you can basically understand. Just basically remember that the starting index, you actually define the starting index by that index itself, and the ending index by that index plus one. That's the only rule you need to remember. Right. Now, what are values can a list contain? List, just like a variable in Python, can contain any sort of values. So it's not like C++ where an integer list can only contain integers. A list can contain all different types of values. So for example, my list is equal to, I don't know, 1, hello. I'm going to add in a Boolean. I'm going to add in none type. I'm going to add in floating points as well. Yeah, this is a valid list in Python. See? So that's about that. So that's about lists right now. Let's actually go to the next section, which is sort of very similar to a data structure like lists, and this is basically what we call tuple. Let me just. All right. So, actually, before tuple, let's actually do one more thing. Here's something really cool about lists. So instead of so when I uh, when I need to define something like that, you can and let's say that these 10, 20, 30, and 40 and 50 actually have some pattern in it, so I shouldn't have to write all of this from scratch. Like, what if I need to write numbers from 110 to 500? I'm not going to go write 10, 20, 30, 40, 50, 60, 70. It's going to take way too much of a time. So Python actually gives us a really interesting tool that if whatever's going to be contained in that list is going to be like a functional value, like a result of some function, you can actually use something known as list comprehensions. All right. I'm gonna on one hand I'm gonna write this, and I'm gonna name another list, which is I'm gonna start writing the list with open brackets, and I'm gonna do just follow me, and you're gonna understand this. A for A in range 1, comma 6. Let me just print my other list. Yeah. So sorry. So uh, this so range 1 to 6, as you must have realized that it's going to start with 1, but it's not going to go till 6, it's going to go till 6 minus 1. Range is basically a function which will iterate through a particular range which you're going to be defining. So let's actually just talk about range for a second. This is, by the way, range. So um, range 1, so let me just write range 6. um, Range is a particular iterator in itself, so it's going to return something like this. And if you want to convert it into a list, I'm just going to do list. List is a function in Python, by the way. Like, that's the keyword that I warned you against. Not to name your list as this keyword, because if you're going to do that, Python is not going to know that you're referring to this function anymore. So you cannot use this function ever again in your piece of code. If I'm going to write this, I'm going to get all the values from 0 to n minus 1, right? I can actually make sure that I don't necessarily start with 1. I can start with any other number. So when I'm going to say range 1, comma 6, I'm going to start with 1, but I'm going to end at 6 minus 1, that is 5. So I'm going to get 1 through 5. Yeah, I can also write this as a negative number. So minus 6 to 6 is going to start with negative 6, but it's going to end at 5. You can also use strides. So it's not necessarily that the difference between two numbers has to be um, 1. It can also be some other value. So I'm going to say 0.1. Let's say the difference has to be 0.1. So it's going to go from minus 6 to 5 steps of 0.1. By default, this value is 1, by the way. Okay. Right. Yeah. I just put in 2 for now. Minus 6, minus 4, minus 2, 0, 2, 4. And then 5, you cannot go beyond 5, so it's going to stop at 4. It won't go to the 6. Yeah, so why did that give me an error when I where did it go? Yeah, so why did it give me an error when I put in 0.1 for a strike? So let me just show it to you again. 0.1. um, yeah, that gave me an error. So float object cannot be interpreted as an integer. So what essentially Python is expecting that the first number is an integer, second number is an integer. So how do I actually like how do I how do I travel from one integer to the other integer using floats? Yeah, so Python actually gets confused over here. So what we need to do is something known as homogenize, meaning that the starting value, if your stride is going to be in floating number, which is zero point 0.1, the starting and the ending numbers also have to be in integers. So I'm just going to go minus 6 point and 6 point. So these are floating point numbers now, and I don't think it's going to be an issue now. Oh, Oh, it does give me an error. That's weird. Oh, okay. I correct myself. So range function can only take integers. If I think, yeah. What I'm talking about, like making strides through floating point numbers, is actually what we're going to see in some other libraries like NumPy and whatnot. So pardon me. I'm just going to delete it. So whenever you don't want anything, just delete it. On the right side, you're going to see this button. So you can either do delete or you can do a CTRL-D. I'm just going to go delete. That's okay. All right. Yeah. So over here, what I did was that for A in range 1 to 6, just return A in that list. And it basically return me 1, 2, 3, 4, 5. Since I want 10, I'm just going to go, basically I need to multiply this by 10. I'm just going to go A star 10, and I think it's going to return 10, 20, 30, 40, 50. Yeah, so this is what you call a list comprehension, that using a function, I mean, this is a function essentially. Um, you can create lists by not having to type everything from scratch. All right. Coming back to tuples, um, a, like a list is actually defined by these square brackets, right? A tuple is defined the same way, but it's defined with uh, circular brackets, round brackets. And it's going to be the same 10, 20, 30, 40, 50. My tuple is I'm just going to print my tuple, and I'm going to get this the same set of values, but with square brackets rather than, sorry, with round brackets rather than square brackets. Uh, what's the difference between a list and a tuple? So the most important difference between a list and a tuple is that you can actually change values inside a list, but you cannot change values inside a tuple. So a list is mutable. I'm just gonna write it over here. Difference between a list and a tuple. Uh, can you actually differentiate? No, okay. List is mutable and a tuple is immutable. Let me show you what I mean by that. So do you remember that we had my list? What does my list contain right now? It contains all these different values. And my list, the first index is going to be 20. The zeroth is the first value. 1 is the second value. Second value was 20. The first index of my list was 20. What if I want to change it? Let me just change it, all right? And I'm just going to assign the first index of the list to some other value. It's 20 right now. I'm going to assign it, let's say 100. Let me just print my list again. And look at this. And there was 20 over here, but now it's 100. And it's going to remain that forever. So you can actually change the values within a list. But can I do that using a list, using a tuple? I don't. Let's actually check. Tuple 1. It's probably going to return me, but can I reassign it? Can I put a value of 100? This will probably give me an error. Yes, it does. So I'm just going to right over here. This will give you an error. Tuples are immutable. Right. So when would you use one over the other? Uh, use so there are a few advantages to a tuple. Like you would say, well, I mean, like mutation is like a flexibility. So why shouldn't I just use lists? And that's completely valid. Most of the times we would be using lists. There is some speed as well as memory advantages when you come to tuples, because I mean, inside the compiler doesn't even have to consider the fact that it is a possibility to that the tuples are muted, that can be mutated. So it's never going to be running those checks every time. It doesn't have to compile that pieces of code that corresponds to traversing through a particular index, changing its value, and then return coming to the initial pointer, returning the initial pointer. I mean, by the way, if you don't understand all these jargon, that's completely okay. If you have some experience with C++ or something like that, you would probably understand what I'm talking about. But if you don't, that's completely okay. Just let it go. All right. Uh, all right. So this will give you an error. But again, um, one thing that I want to point out, tuples, just like lists, can contain different values. So just like we did, we created a list over here, you can also create a tuple. Yeah, so I was talking about why would one use tuple over a list. Uh, you don't need to, but like if you basically know that something is most more likely immutable, it's going to give you some speed and memory advantage. Just use it otherwise, and we're going to see when we're going to use tuples. For most of the times lists just work fine. I mean, memory is not that big of an issue. I mean, because gone are the days when you would be running with uh, I don't know, 4 MB of total RAM. Now you have RAM. Like, just check your RAM. By the way, over here you're gonna see something like RAM and disk. I have some 13 GB of RAM over here. I'm not gonna run out by some because of some, I don't know, point 0.1 or 2 or maybe even 1 MB of difference. So lists are fine. And let software engineers worry about the memory usage. That's not something that we need to worry about as of now. So yeah, let's go ahead. All right. Now that we're done with lists, I'm going to be starting with something known as functions in Python. What is a function? So if you've studied some basic math, you know that function is like some mapping from some input to some output. So for example, I can write a function that's going to take in a number and give me, I don't know, twice the number. So if it's going to take 2, it's going to return the value 4. That's a valid function. Yeah, so that's a mathematical function. So in programming, you have the option to write functions. What's the advantage of functions? Well, I mean, functions have a few good advantages. We'll see what they are exactly. But let's actually just get started with how do you actually define a function. So let's actually just define this function that I just talked about that takes in a number and returns twice that number. So the way you define functions in Python is using this keyword called def, def. So I hope you all are following me. If you don't, pause it, go back, read it. I mean, understand it again and again. Google whatever you do, whatever you have to, and just make sure that you understand these concepts really well because we're going to be using them very extensively throughout this course. Uh, I don't know. Let's actually, and followed by def, you actually name your function something, just like in maths, you name your function f or g, just so that you can reference it later on. Otherwise, you can't just be like, oh, that function, that function. I don't necessarily know the name, so you need to name your function, right? Uh, what should we name this number? I don't know. Price number. That's gonna be the name of this function. And after that, I'm gonna need you to open the round brackets. And what we're going to enter inside is, let's say, x. So what this essentially means is that there is a function named as twice a number. It takes an x as the input. It can you can basically, if there's going to be two numbers, you can do x comma y, inputs x comma y comma z, and you don't necessarily have to name them x. You can name them a, b, c. You can name them plush, I don't know, Rohit, Arjun, whatnot. It doesn't matter, and it also doesn't matter that you defined it before. So this is an environment on its own. A function is an environment on its own. So what are we going to add over here? It only refers to some arbitrary variable inside the function. It does not matter that you've defined Palash outside or Rohit outside, Arjun outside. So yeah, let me just show you. Let me just. So if you remember, I think I've Uh, so we've used a function, a variable over here, my variable. I'm just gonna use it anyways. I can put in my variable over here, but just for the sake of like so that people don't get confused, I'm just gonna go x. X is probably the most intuitive because like all mathematic functions are usually defined with y is equal to fx. X is like probably the most famous way. Once you write that x, you need to write a colon in front of the function, which basically tells you that I've now started defining my function. And I'm gonna press enter, and I'm gonna say return. Return is basically a keyword which will do some calculation and give back the value whenever you call that function. So return x times 2, right? Does it work? Let's see. I don't know. Twice number. Let's give it an let's give it an input. I don't know, 5. Is it going to give me the value? Yes, it does. I can do different types of values as well. So a floating point will probably give me 10.0. I mean, float multiplied by an integer is a float, just as I told you, if you remember. Let's actually modify this function and let's say square of a number. Now, square of a number is basically x exponential 2. So if I add in a number over here, I would expect the value 25. Of course, I changed the name of the function from the change it up to 25. That's right. All right, it works. And what I basically can do is that I can assign the output of that function to another variable. So y is equal to square of a number 5. And so y is going to have the value 25 now for eternity unless you change it again and again. So um, yeah, so that's how functions basically work. And you can write functions of all complexities. I mean, all right, let's just write different kinds of functions so that you get an idea about what kind of functions you can write. I'm going to write a function that adds two variables. I'm going to take in two inputs, x and y. And basically, I'm going to be returning x plus y. What happens if I do add two variables, 10 and 20? I'm going to expect the answer 30. And that is right. All right. A function need not necessarily return only one value. It can also return two different values. So what if I want to return both the addition and the subtraction of two numbers? You can absolutely do that. Def add and subtract two variables. I'm gonna take x and y. I'm gonna return. Don't forget the semicolon. And I'm gonna return x plus y and when you want to return more values, you separate them by comma. Make sure of that. And x minus y as well. I'm going to do add and oh, here's very interesting thing about Jupyter Notebooks. You must have noticed when I started writing add and so it automatically gives me an autofill suggestion, like what exactly can this function be, and so that I don't actually have to type the entire thing. It's very boring. So when you get this suggestion, just press a tab and it's going to complete it for you. Let's do 10 and 5. I would expect the answer 15 and 5. Let's see. Yep. Here's one very interesting thing. It returned them to me as one particular variable, which was stored as a form of a tuple. So this is one peculiar thing about like functions, because functions expect these things to be immutable. Like how do you expect them to mutate from one different function, from one different value to another, like during extraction of values from functions? So they just return tuples. So when I would do a is equal to add and subtract two variables, and I'm going to print a. A is a tuple. Let me actually also just do just type a, and you're going to find out what type is it. So it's 15, 5, and the type is tuple. Again, this entire thing is a tuple on its own. Just a very interesting thing. I mean, don't break your head upon it. But because I separated two different values by a comma, it assumes that it's a tuple as such. Here's one thing that you can do. I'm going to be talking about something known as decoupling. which basically means that given a tuple, how can you actually store all these values in different variables? So if you simply do a comma b, so you would expect uh, a to have the value 15 and b to have the value 5. And using this, you actually made sure that so essentially what is this? I mean, like, you can make sure a comma b is equal to x plus y comma x minus y. So it just knows that x plus y refers to a and x minus y refers to b. So it's not gonna, a and b are not tuples anymore, they're values on themselves. So a is, I don't know, 15 and b is 5. uh, right. It's actually so yeah, that's about functions. Let's talk about, I don't know, if okay, let's actually move ahead. Let's actually go to another topic. I'm going to be writing something known as if else conditions. So what are if else conditions? uh, how do we use if and else in our everyday lives? We basically go that, um, if if something, I mean, if something happens, do this. Otherwise, if this doesn't happen, do something else. So you're conditioning your life, you're conditioning your environment. You have certain conditions. If they meet, if those conditions meet, you do something. If they don't, you don't do that. You do something else, for example. So, yeah, let's talk about uh, um, if else conditions. Uh, all right, so that is pretty much the same in Python as well. So for example, I'm gonna do two variables. I don't know, a1 and okay, x and y are pretty convenient. Y is equal to 1 comma 2. Right? If x is greater than y, greater than sign is given by this sign over here. Then print x is greater than y. Else, if x is not greater than y, print y is greater. Sorry, x is not greater. Ideally, I mean, whenever you write a semicolon, you should probably write it in the next line. But I mean, uh, yeah. So this is actually the correct syntax, to be very honest. But if, I mean, within this, you can actually do all sorts of things. You can actually run different, like multiple lines of code within one if block, within one else block. But if you have only one line of code to be executed, you can actually just write it in the same line. That's perfectly okay. So this is valid syntax actually, because we only need to execute one line of code. So let's see what would be the answer. I would expect the second line to be executed because x is indeed smaller than y. Yeah, x is not greater than y. Yeah, so this is how you write if else conditions. Right. All right. So how about we combine functions and if else conditions? So I'm going to do def. Let's actually write a function that checks if a number is even or odd. Is even, so it's going to return true if the number is even, and false if the number is odd. So how do you actually check if a number is even? You first divide it by 2 if the remainder is 1, right? Uh, if the remainder is 1, it's odd. If it's 0, it's even. Uh, so, all right. There's another operator in Python. So, okay, let me just write it. If x, uh, okay, how do you find the remainder of a number? In Python, there's this operator known as percent sign, which will basically give you the remainder when you divide that number by the other. So when x is divided by 2, it's going to give you the remainder that x is going to give you with 2. If it's equal to 0, and I'll also talk about like how do you compare two different values in Python. For now, you can just follow me. Just write 2 is equal to signs. 2 is equal to 0. Now, I don't know, return true, else return false. Right? And let's see if it works. Is even 33. 33 is an odd number, so I would expect a false. Yes, it works. What about 34? I expect it to be true. Yes. Right. So, okay. So that's the definition of. Uh, so that's how you use if-else condition within functions as well. If can contain this return value, this return statements as well. Um, Also, let's do one more thing. I've only showed you how to execute one statement within an if. Let me do two. Print this number is even. Now, because there are two statements, I cannot write in the same line of code. I need to press enter before I write anything. Print this number is odd. It doesn't work. I first expect it to print this number is even, then it would return me true. All right. Okay. So what have we done till now? Yeah, we've done functions, if-else conditions. All right, let's actually look at another new concept now. This is called for loop. So for loops are functions. So what is a loop, by the way? A loop essentially means doing something again and again. So for example, if I want to compute the square of numbers from 1 to 20, we can simply write a loop function which runs again and again, taking different inputs every time. Right? So you don't necessarily have to do square of 1, then print square of 2, then print square of 3. You can just do a for loop that runs across a list of values, uh, and it will give me some value. So let's see how it works. I'm gonna actually write a list. So let's actually work on this problem that I want squares of values from 1 to 20, integers from 1 to 20. So to define a number from 1 to 20, remember what I need to do? Uh, I'll use a list comprehension, but yeah, you can simply do list range 1 to 21. So it's gonna start from 1. It's gonna end till 20. If you remember. Let's see if it works. Yep. All right. So for I in my list, so what it's gonna do is it's gonna go over my list. And like for example, I is gonna first contain the value 1, then 2, then 3, then 4. Yeah, so that's what's the meaning of for I in my list. Um, Print I square. I forgot to add range. So so see, very interesting thing that happened over here. I defined a tuple over here that is 1 comma 21, and I converted it to a list. You can also do vice versa, by the way. List can be converted into a tuple can be converted into a list. So essentially my list was basically 1 to 21 and not 1 through 21. So I need to add this word range over here. Yeah, 1, 4, 9, 16, 25, blah, 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 blah. Yeah, so it works. Yeah, so this is how you write for loops. One thing to note over here, I is only a dummy variable, meaning that it's a temporary variable to which we give the values in my list, right? It's actually just like plain English. Like you can simply guess like what it means when you say for I in my list. Basically means that for a number, which for the sake of simplicity I'm going to call I, in the list called my list, do something. Like, isn't that simple to understand? Yeah. So that's exactly what you mean by that. That's exactly the meaning of that. That's how you form for loops. You can actually do different things. I don't know. Let's print different things. You print a square, but I'm also going to be printing is even. I'm going to check if the number is even or not. But I'm actually also printing a few things. So I don't want this number is even and this number is odd. So I'm just gonna comment them out. I'm gonna run this code of cell again. Whenever you make some changes, you need to run that piece of code again. Uh, yeah. One false, four true because two is true. Three is not an what do you call odd even number. Four is an even number. Five is not. So on and so forth. Okay. Uh, all right. So that's a for loop. Let's also talk about a variant of a for loop, which is a while loop. And we can actually check the difference between a for loop and a while loop. But essentially, you can, depending on a use case, you're going to be using one or the other. Here's what you're going to use this for. I'm going to initialize some variable, I don't know, I is equal to 0, for example. And I'm going to assume that while I is less than 10, do something. I don't know, print I square. But then, and what it's basically going to do is that you're going to go and set while basically is gives you the end condition. Before entering into the while loop, it's going to check is I less than 10 because I is 0 right now. Yes, so it's going to go and set it's going to print I square. It's going to again check is I less than 10. I is still less than 10 because I is 0. So it's going to keep on printing I square, which is 0 square, which is 0, 0, 0. So you need to update that value. So I'm just going to go I plus is equal to 1. This is very similar to C++ or something in which we used to do I plus is equal to something or I plus plus. I plus plus does not exist in Python, but you can do I plus is equal to 1, which basically means whatever value I has, if it's an integer, it's going to add the value 1 to it. Uh, yeah. So let's see. Yeah, it works. So it went from 0, it became 1, 2, 3, 4, 5, 6, 7, 8. When it came to 9, it printed I square, and then I became 10. And now when it went on to check, is I less than 10? Is 10 less than 10? No, 10 is not less than 10. 10 is equal to 10. So it stopped its operation immediately. Yeah, so that's that. Uh, what should we do next? Uh, let's actually talk about some object-oriented programming now. Classes. Uh, Very important. So it's probably one of the most important concepts. One of the most important concepts in any software engineering slash Python, I mean deep learning model development. It's basically gonna be a life savior in more than one opportunities. So just make sure that you understand this really well. How long is it? All right. So at the very core of object-oriented programming lies this concept known as classes, right? So what is a class? A class is basically a house, a bunch of different objects, a bunch of different things that can exist together as one entity. So for example, I am sitting in my bedroom. There is my parents' bedroom. There is a living room. There is kitchen. All these are different rooms, but they're all bound together by one common entity, which is known as apartment or a house or a bungalow or whatever. So that's exactly what a class is. A class is basically a collection of very different things which are bound together by this entity, which is known as the class itself. Class has a name. And so whenever you want to refer something that whenever you want to refer to, let's say, particular my bedroom, you'll first have to refer to that house, that apartment, that bunch of objects. So you're going to go to the bunch of objects, and once you reach that, you're going to be like, okay, let's actually now, once I've reached this house, now where is this bedroom, particular bedroom? So that's essentially the role of a class. So class is defined by the keyword class. And we're going to name something just like functions, we're going to name it something. I'm thinking of creating a class of which contains information about a student of this course, the deep learning course. So I'm going to name it, I don't know, deep learning student. Um, just I'm going to in some round brackets in front of it. We'll talk about what it's meant for later on. All right. So all right, so let's talk about how do you actually define classes. So right now, I don't want my class to do anything. So whenever you don't want a function or a class to do anything, you just write the keyword class, and it's going to do nothing. All right. Now, class is just an idea, right? A deep learning student is just an idea. But then, for example, Palash Agrawal is a student of deep learning. So Palash Agrawal has value. I mean, deep learning, me being a part of deep learning is only a concept that defines me. But like it does not exist in the real world. Palash Agrawal, exist in the real world, and I'm gonna be an example of a student who's in a deep learning course. Do you get this idea? Right? So this Palash Agrawal is actually an object of the class deep learning student. So here's some terminology. And object is going to be the thing that's going to exist in reality. Class is the definition of the class is just going to be a description of anything that's going to be object of that class. So let's actually, yeah, my name is Palash. So Palash is equal to deep learning student, right? And yes, now if I'm going to do type Palash, it's going to tell me that I'm a student of deep learning class. So yeah, deep learning student. So Palash is an object of the type deep learning student. Does it make sense to you? Right now, it's not going to do anything because we've asked it not to do anything. So this process of assigning a variable and a class description is called initialization. And essentially, um, Python gives you control over what you want to do when you initialize something. So, for example, when you initialize a class, you would want something to happen. For example, we'll actually talk about that. So, when you actually want to control over how you want to initialize your object, you're going to be writing a function which is known as def underscore underscore init underscore underscore. It's very standard. Um, so this underscore underscore is actually called dunder. Uh, dunder init. So this is how you pronounce it. So dunder init is actually gonna define uh, how you will actually initialize your function, and we're gonna see other functions as well. Uh, this is essentially a function because you see def, so it also has to take some input. In classes, it's a very standard syntax to actually use self, variable self, as the uh, as the argument of that function. What does self mean? Self basically means it refers to itself, the class, the object. So when I'm going to say Palash is equal to deep learning student, self refers to Palash now. So right now, I mean, self refers to deep learning student. When I'm going to send it to Palash, self is going to refer to Palash. So I'm talking about initializing Palash, which is why we write self. You can essentially write it anything else. You can write it, I don't know, name. You can write it donkey. You can write diamond. Doesn't matter. But it's very common to write self. And after the self, of course, you're going to have the open semicolon because it's a function. I'm just going to say print initialized student for the deep learning class. And see what's going to happen when I run this piece of code right now, because I now took control over how I want my function to be initialized, how I want my object to be initialized. When I initialized Palash, it went over here, this function, and it saw, what do you want me to do? It says, I want, and I said that I want you to print this statement over here, and that's exactly what it did over here. What you can do inside a class is you can define, you can actually store certain attributes. For example, a student of deep learning class has probably a few attributes. A person has a name, of course. So I'm gonna write a name. So self.name basically means that, since after I'm gonna assign it to Palash. So Palash.name basically means that the name which belongs to the student Palash. So name is an attribute of the object Palash. Just like this bedroom is an attribute, a component of this apartment, right? So I'm gonna probably just hard code it for now. I'm gonna have an age. I'm 21 right now. What else? Oh, and yeah, I'm gonna print. Uh, got a student of age. Um, Now, actually, since I've actually defined age, so age does not exist. It's self.age, by the way, because you're always referring to the variable that exists to a particular class. So self.age. So I'm going to expect got a student of age. So when you write statements, and you can write n number of items that is separated by colon, by commas, and it's going to print all of them sequentially. What do you expect to happen? So let's see. So when inside init, it assigned the name Palash in 21 to say self.name and self.age, which are variables now, and it printed this, which I wanted. So it knew what self.age was, so it printed that. You can, by the way, go Palash.age. I'm gonna get 21. You can do Palash.name, and I'm gonna get the name as well. Yeah. So uh, that is pretty much that is what you mean by initialization of a course. So now name and age have become the attributes of Palash, and I can access them whenever I want, right? And it's going to be useful when we design neural networks, as you'll see. So um, not only have control over how you want to initialize the object, but you can also have other methods inside your class. So I'm gonna write a function that's gonna return twice the age. I don't know if it's gonna be of any value, but okay. Right. I'm just gonna go. So if someone accesses this particular method, I'm just gonna return self.age twice two. Makes sense. All right. Oh, make sure whenever you write function, the self is very important. And I'll tell you why. So okay, now I'm gonna go Palash dot twice the age, and it's a function, so it has to go with round brackets. And let's see what happens. It returns twice my age, which my age is 21, so it returned 22. Uh, you would imagine that since it's a function, and I said that it takes a particular value as input, why does it not give me an error when I did not enter any particular value? So here's one thing about classes. When you write Palash dot twice the age, it's essentially the same as twice the age. So that is why I was talking about that self refers to Palash. So, and these two are equivalent actually. This is like something that's specific to Python. So, which is why when I actually went inside Palash and I went twice the age and it took an input which was Palash itself. So it went return Palash.age, which is 21 times 2. All right. Yeah, so that's about that. Let's actually um, make this much more. Let's go one step here. Now, I was talking about how you have control over uh, uh, what you can do with your classes. So one thing that you can do is that you can actually add in other input variables inside your init, and that you're gonna store it inside your class. So here's what I mean by that. I'm just gonna redefine this. I'll just copy this class over here. Um, what I can do is that after self, I'm going to add in one more variable. It's just like functions. So the first, because I mean, self refers to Palash, and then I can add in more variables just like I can do in function. Like function can be f of x or fxy or fxyz and so on. I don't know, name and age as well. Right. Now I don't need to hard code the name Palash. I can simply go self.name is equal to name, self.age is equal to age. Uh, else self.course, I can hard code it for now, is equal to CSF425, 425 learning. And yeah, that makes sense over here. And I'm going to define another function over here, def4 times the age. And here, I want to I want to show something over here that you can actually use one method inside another method. So how do you actually do 4 times the age? You first do twice the age and then you do twice the age again. So I'm going to do twice is equal to twice the age, right? So self dot twice the age. So make sure you do that. So again, self refers to Palash over here. So this is equivalent to twice the age, which and it takes Palash inside its bracket. But note that you cannot. I mean, even though this is equivalent, these two things. I mean, this is valid, and this is probably going to give you an error because Python would not know that twice the age is a function on its own or it's a function that belongs to a particular class. So you need to first go to a class and then only you can go to its method. You cannot simply go twice the age and expect Python to scan every object, every class, and go inside each of those classes and find out if that function exists. Which is why this is the correct syntax, which means that the Python compiler will first go to Palash and then it's going to go to its method twice the age. But it's going to be equivalent to this syntax. So that's what I meant by that. And I'm just going to go return twice times 2. Yeah, that makes sense. Let me initialize my student again, deep learning student. Now, make sure that self is something that we never initialize because like when you're doing init, self is actually taken care of. I mean, deep learning student itself is self for its own, so it makes sure that uh, um, like it itself is an input for the init dunder init function. So I can skip self and then I need to enter name and age. So that's gonna be name is gonna be Palash. It's gonna be 21. Now I'm gonna do Palash dot STH and I would expect 42 again. Oh, let's just for the sake of it. Let me 18 and I would expect 36 now. Sorry. Twice age. Right. Oh, Palash dot 4 times the age. Yep, that works too. Yep. Right. So that's about the basics about classes. Now let's talk about inheritance. What is inheritance? You may or may not have heard about this concept, but I'll just let you know about it anyways. So one class can actually inherit or derive characteristics from other classes as well. So what this essentially helps us with is that you don't actually have to write everything from scratch. A lot of the properties of the class from which you're gonna inherit is already going to be present for you, so it's just gonna make your life easier. For example, a deep learning student here in BITS-DeepLearning has one common characteristic. I mean, like, you can be a student of deep learning course or the machine learning course or the object-oriented programming course, or you can be part of, I don't know, digital image processing, some student of chemical engineering, but you're going to have one thing in common, that you're going to be a BITS-DeepLearning student, right? So let's actually define a class that says that actually defines a BITS-DeepLearning student. So I'm just going to go BITS student. Right. I'm gonna define a few things. I need to have control over how I'm gonna initialize this. So self is always there. Name, sorry, name, age. Is a student a PS student or a thesis student? So this PS is by default true. Oh, this is something that I didn't talk about. In functions, you can actually have default values. So for example, x is equal to 0 by default. This is what I do. So when I enter a input that is, let's say, 5, it's going to override this default value and it's going to say x is equal to 5. So it's going to return 25 to me. But now let's say that I just decide not to enter any particular number, any particular input. So it's going to go with the default value. It's going to say, okay, since I did not get any x, I'm going to assume x is equal to 0 and I would expect the answer 0. So that's how default values work. Um, okay, so I assigned a true default value because the student, when they first come to BITS Pilani, is a first a PS student. If he's a thesis student, you can obviously put it false manually. Otherwise, it's going to be assumed that it's true. And what campus are you from? I'd assume that you're from Pilani campus by default. If not, you have to manually identify which campus you're from. So yeah, Um, so name, age, is PS are just temporary variables. So we need to make them permanent by actually storing them as class objects, as class methods. So, and you do that using self.name, self.age, self.course. So you can access self.course anytime throughout that class, but you cannot access name, age, and these variables outside of this function def in it, def render in it. Self.name is good name, self.age is equal to age, self dot its ps is equal to its ps self dot campus is equal to campus. I'm gonna print one nice thing just for the sake of completeness. I'm gonna go print. Uh, this is a student of uh, campus of BITS Pilani campus, which is going to be Pilani, Hyderabad, and Goa campus batch. Um, let's see, I'm 21 right now, and I would have wanted to show 2018. If a person's born in 2001, they would be from 2019 batch. So, and it's 2021 right now. So 2021 minus 21 right now. So I've got age and plus 18. Yeah, yeah. This is gonna give me 2018. I think so. Yeah. Yep. Let's see if this works. Yeah, this will probably work. Yep. All right. I'm gonna put in a method. Let's say that's gonna print ID the student. That is college ID. So self. Um, Go ahead and say. So I would expect it to give me 2018. That is this value 18, and I'm just gonna assume it's gonna be something A3, A whatever, AX. Uh, yes, or it can be thesis as well, which I need to do, and then four numbers uh, followed by campus, right? Yeah. So I need this value. I'm just gonna go return. Uh, so this is, by the way, a string because like 2018 may be a number, so I need to convert it to a string because like all the other things are going to be A, PS, P are going to be strings. So numbers and strings cannot be added. So if you want to really concatenate them, you need to first convert numbers into strings, and that's very simple. Um, let's go str, which is the function to convert anything into a string. Um, 2021 minus self dot age plus 18 plus ax plus yes. So yes, or a thesis, right? So I need to assign it to a variable actually. Um, Follow me, and it will become clear with you. If if self dot ps else thesis, yes, plus some four numbers and followed by the first letter of the campus. So I need to index my string, and indexing a string is the same as indexing a list. So the first element is given by the index 0, and needs to be capital. So strings actually have a actually have a method. String is also a class, by the way. So everything that you see in Python is most likely a class. When we saw list is a class. Tuple is actually also a class in itself. Strings, integers, floats, all are classes in themselves, and they have certain characteristics which is defined by Python internally inside those classes. So just some common knowledge for you. So dot upper actually a method of the class string, right? So essentially what it's going to do is that, so it must have been defined something like, def uh, upper self, and it would take in an input, sorry, yeah, and would probably return the capitalized version of that. Yeah. So yeah, I think this would work. See, um, so I don't know, uh, flush is equal to student name flush is 21. I'm not going to add other values because they already have default values. And I would expect to print out this is a student of BITS-Pilani campus of batch 2018. Yes, it works. Let's do Palash dot print ID. Oops. Name campus is not defined. Of course, campus is not defined. We need to do self dot campus. Right. Yep, it works. 2018 AX PS XXXP. Yep, it works, and you can play around with it. It's a fun exercise. Now, a deep learning student also has characteristics from bit student, right? Because I mean, like, if you would probably like to access the ID of a student from Bits Pilani as well, from deep learning course as well, and you shouldn't have to write this piece of code again and again. You can simply inherit or derive properties from this class into another function. So I'm just going to redefine this function over here. I'm just going to copy paste it. Uh, for inheritance, all you need to do is that the first line where you left that round bracket empty, just enter the name of the other class. So yeah, so now it basically has inherited everything from bit student. So if I were to simply um, not write anything, right? Let me just comment out everything that I've written till now. So it basically contains everything from bit student, and I can basically initialize it the same way. Um, I'd say Palash. When I would say deep learning student Palash.18, I would expect it to print this line of code is a student of BITS Pilani campus 2018. Not so 2022 actually, because I've changed my age over here. Let's see. Anyways. Oops. Oh, I'm sorry. Yeah, no. Unexpected indent. Oh, okay, of course. Um, since I'm doing nothing, I need to do a pass. If you remember, otherwise it's gonna give me an error. It's gonna think that I'm gonna write something inside this piece of code. So I need to tell it that I'm not gonna do anything by writing pass. It should work now, I guess. Yeah, this is a student of BITS Pilani campus of batch 2021. Yep, it works. So deep learning student has now become just a proxy, just a copy of bit student. What I can do now is that I can modify this bit student according to my own needs. So when I'm going to be defining, so I can either add in new methods or I can override the existing methods. So when I'm going to say def twice the age, I'm going to run it again. So Alash will now have the age method as well. Yep. It wouldn't have been possible. So I didn't define twice the age in bit student. So bit student doesn't have that characteristic. But deep learning student, because now I've defined it, actually has this characteristic. Now, what if I want to change the initialization methods? I don't like the initialization method that is used in bit student. That's perfectly okay. I can simply rewrite everything. All right. So let's actually run this again. I would expect it to give me got a student of age 18. Yeah. So it didn't actually go with this is a student of BITS Pilani campus because I've overwritten this dunder init function. Now, what if I want um, okay. By the way, now even though I've overwritten this init function, twice the age is just an added function, and I also have print ID as well. Print ID is not going to work. It's going to give me an error because like I've not defined self.sps now because I just overwrote the init function, so it does not know what set.sps is. So now, what if I actually want to also run the initialization of the parent class? So, by the way, bit student is called the parent class. Deep learning student is now called the child class. So, a child inherits from its parents. Makes sense, logical sense. Uh, what if I also want to initialize uh, the parent class along with my new class? So what I'm going to do is that I'm going to inside my init function, under init function, I'm also going to tell it that I also want to first initialize whatever was in the parent class, and then I'm going to run these modifications, that is self.name, self.age, and print got a student of age, blah blah blah. So for that, what you need to do is that super init. So by the way, super basically refers to the parent class. So you're going parent class dot init. So you're actually running the init of the parent class. And now what was the inputs for the parent class? There was self, but we already took care of self in this super. Name, age, SPS and campus are default, so I'm not gonna add them. So yeah, name, age. All right. So it's so I'm gonna anyways gonna be rewriting self.name, self.age. I mean I've overwritten them over here, so it's not gonna matter. Um, but is PS is gonna be true, is campus is gonna be there, and it's also going to print this. Let's see. So at first went into this line of code. It first initialized the parent class and said, "This is a student of BITS Pilani Pilani campus," and then it also went ahead and executed these, and of course printed this as well. Now, um, Palash is actually an object of the deep learning student class, right? You can see over here, but it also has the object's print ID. So I'm just going to go Palash dot print ID. It's going to give me an answer. Yep, it does, and so that is essentially inheritance in itself. All right. Yeah. So we're actually done with Python. Now I actually want to spend some Python and object-oriented programming as well. So I'm just going to take around 10 minutes, 10, 15 minutes to talk about deep learning, what deep learning is. And then like I want to give you a gist about what deep learning is practically. Yeah, you'll enjoy this. So I'm very sure all of you must have heard about what deep learning is. It's such a buzzword nowadays. Everyone wants to get into it. But let's actually take a step back and actually think about what deep learning actually means. So to actually understand what deep learning means, we need to first understand what machine learning means. So machine learning, uh, as the word suggests, is making machines or computers learn or think, about information. Um, if we can teach machines to think, it would make our lives easier since we don't have to do the thinking anymore, right? So, um, so let's actually talk about like a few examples of machine learning and deep learning in our everyday lives. We are essentially surrounded by machine learnings. If you have your phone, I mean, open your phone, and most of gonna like a lot of apps are gonna be using deep learning to make your life much more efficient. You don't have to memorize directions anymore because Google Maps does that for you. How does it do that? Machine learning, deep learning, essentially. Um, Gmail automatically sends spam emails into the spam section, so it doesn't let you appear in your inbox. So you don't have to take the effort to manually delete them. You don't have to know the spellings of words to be able to type in today's world. You can simply start typing, and it's going to give you some suggestions. It's going to autocorrect. That's deep learning. Um, your modern phones also like not just autocorrect but also suggests word like your next sequence of words based on the context. So if you're a person who uses emojis, your phone's going to identify that you're a person who uses emojis a lot. It's going to predict that your next word should be an emoji, and it does it. It's very eerie if you think about it. um, you don't have to learn a local language to be able to visit it because you have Google Translate uh, that translates between your language and that local language very efficiently both ways. I mean, it's getting better day by day. You don't have to take effort to type anymore. I mean, I was talking about typing. You don't need to type anymore. You can simply do "Hey Google," "Hey Siri," "Hey Alexa," um, depending on the device that you have, and it's gonna do whatever task you want. I mean, and really complex tasks like book me a salon and uh, a salon appointment. It's going to do that automatically for you. Get me a pizza, order me a pizza. Even if anyone of you has seen Google I/O event this year, you would have seen that. I mean, like they have systems that can actually hold really intelligent conversations with other people. I mean, Google Assistant can do that, and it's just amazing. Um, so, do you observe a pattern in all these examples that I give? So central idea behind machine learning is to gathering knowledge about different things, and we want to teach machines these different ideas of this world, and take intelligent decisions based on that. So why do we want to do that? We actually want to do it so that we don't have to do that thinking and that minimal that effort. We don't have to take that effort, and machines can actually do that for us. That's actually a very common trend. I mean, history has seen this again and again. Um, for example, back when people used to do manual work, Then came the steam engine, and life suddenly became easier. Travel time cut by from months to it became one single day. Um, uh, it just became much more efficient to run machines, and then life just became. It just started this whole new era called the industrial revolution, right? So that was the first revolution, called the industrial revolution. Uh, Sorry, that was the yeah, that's called the industrial revolution. So before steam engine, if you remember that trade could only be done in local communities, travel was impossible over long routes. We developed as a species, as human beings when travel became fast with steam engine, travel times were cut massively. It implied faster development. So with the second industrial revolution, production of goods became fast and cheap. Humans did not have to produce hand-produced goods. We developed as a race because humans could now focus on more important and intellectual things like developing technology, economics, politics, and so on and so forth. That was us as humans, just becoming better as a species. Third industrial revolution, we discovered that computers can do tasks that we do every day. So computers can handle computation, information processing, information storage, communication systems improve, and whatnot. Internet came. So just 20 years ago, cell phones were not like widely available. Today we have highly evolved platforms to communicate over calls, social media, the traditional media like television. uh, this has not only helped us connect better, it has just connected everything into one single. That's why we call it as a global village. Everything just became better. I mean, we could essentially now, I mean, focus on really amazing things like research, scientific and social research, large scale global trade, space exploration, global economies. This would not have been possible had internet or this communication was not possible. So we as a species moved ahead and we moved to a higher level of intellect. So now we're talking about the fourth industrial revolution, which is AI and automation. And basically what that means is that beyond what we can do, but we still have to do things manually. What if we can actually teach machines to take intelligent decisions and do those things for us so that we can actually move ahead and become more able as a species, work on more intellectual stuff? So that's the entire concept of machine learning and AI. Uh, how do you make machines learn? You can't simply code or gather knowledge. It's not possible because, like, we ourselves don't know like what intelligence means. Like if I ask you to to write an algorithm that takes in a picture and tells whether it's a cat or a dog, you don't know how to describe a cat or a dog. You can probably give say like, okay, yeah, it has some pointy ears, it has some amount of fluffiness, but can you write a concrete algorithm? I doubt you cannot. I mean, like, no one can do that. So we ourselves don't know what intelligence means. And so essentially everything is a function, right? Like it takes an input, it does some function, it gives some output. We don't know that function now, so what do? We now go. So machine learning is all about finding a way around it. So we don't know the function, but we know what the input is and what the output will be. If it's a cat, you're gonna give a prediction that this image is that of a cat, right? So machine learning is all about developing systems, algorithms that can identify patterns within data, these input output mappings, and come to some arbitrary function, derive some arbitrary function through optimization methods that's gonna help you take one input and give you one output. So, what is deep learning now? Um, there are a lot of different types of machine learning. Um, But there is one particular type of machine learning which has basically overtaken everything else. That is called a neural network. And a neural network is so flexible. I mean, I can't think of any field which does not use neural networks now and uses some other type of machine learning. 99.99% of all research in AI and computer science is neural networks. And which is why, because it's so famous and it's so vast in itself, it has been given its own name and it's called deep learning. So, let's actually here's what I want to do in this course. I don't necessarily want to give you redundant information. I want to help you just build your models right away. I mean, like, without any practical experience or without any much prior experience. I mean, you should be able to build your model from scratch. You should be able to learn how to practically implement your concepts that you're going to be learning in class. And so for now, what I'm going to do is that I'm going to use a library, and we're going to build a state of the art a deep learning model that's going to take in an image and it's going to classify it into a cat or a dog, uh, or a different species of a dog actually. And we're going to do it with very less lines of code. You're going to count it and you're going to be surprised how easy it is, and it's probably going to help you motivate you to pursue deep learning in the future. So to do that, you first need to actually go to runtime and change the and oh, sorry, go to runtime, change runtime type, and you're going to see an option known as Harvard Accelerator. So it's going to have three options: none, GPU, and TPU. None basically means CPU. So anything that we've been running right now is a CPU. We need to run it on a GPU. A GPU is basically like a faster version of a CPU, which is essentially meant for systems like deep learning, because neural networks are very slow on CPUs. The reason for this, we'll probably discuss sometime else. So you need to choose a GPU and do save, and it's going to restart basically. Oh, sorry. Once you've done that, you actually need to. Yeah, okay. So you're done. Anyways, I'm going to be installing a library called fast.ai. It's a wonderful library, though we're not going to be using FastAI a lot throughout this course because I want to implement a lot of things from scratch. This labs will be based on PyTorch. But just to get started, just to give you a gist of it, and just to get models around really fast, I'm going to be using FastAI for now. So just follow me. I'm going to do pip install FastAI. Did yeah. Uh, this, exclamation mark basically means that it's not a Python line. It will basically be running in the Linux system that is actually running this notebook. So if you remember, if you've done your first year course, you used to first write commands on the Linux subsystem, putty or whatever, and then after that you used to go to text editors and there you used to write actual Python or C++ code. So this is essentially the same. Jupyter Notebooks gives the ability to actually run Linux commands right from the Jupyter Notebook itself. And how do you differentiate it? Using this exclamation mark. Here I'm going to be installing the FastAI library. And I'm going to do from FastAI.vision.all import start. Just follow me. Don't need to necessarily understand what's going on. And let it run. So it's going to actually go right. So if you see this kind of an error, it basically means that so it was installed, but you have to actually you have to restart the runtime in order to use the updated version of it. So just go I don't know, restart. Sorry, just restart will work. Yeah, and I don't need to run everything from scratch from the top. I can just run it from here. So yeah, I'm gonna run this. I don't think it should be an error now. Till the time it's gonna be running, it's gonna show you this round thing over here. So yeah, that means essentially it's running. And it ran. Yeah, cool. Okay. Just follow me. First, I need data. So I'm gonna download it from from the internet. Just follow me. Don't necessarily have to understand what's going on. Just understand that this is like what's going on from a broad overview. Um, I'm going to be downloading this dataset called the PETS dataset, which contains different breeds of dogs and pets. And our task is to classify, given an image, what breed of that cat or dog does it belong to. So I'm going to be downloading this data by using this line of code. So it's downloading. You can see it'll take about 30 seconds in total. Yeah, it's pretty fast. So what essentially I'm doing over here is that I'm downloading the data and storing it at some particular location. That location I'm going to be naming as path. So path is root slash dot fastAdd slash data slash Oxford triple IT pet. So by the way, this is the data set that we're working in, Oxford triple IT pet data set. Yeah, so it contains 37 categories of pets with roughly 200 images in each class. These are dogs and cats, different types of dogs. So Abyssinian, what is it? Abyssinian, Bengal cat, Bombay cat, Burman cat, British Shorthair cat, Maine Coon cat, blah blah blah. What about dogs? English Cocker Spaniel, Newfoundland, Pomeranian, Leonberger, Beagle, Havanese, English Setter, whatnot. All right. So I've downloaded it and I've stored it inside this path, which is defined by this. So I need to extract my data from this particular path. All right, and now I need to visualize my data set. So I'm going to be converting it into something known as a data loader, and we're going to talk about what that means. Um, so just copy me. Don't think about what's going on. Um, and if you think if you need to catch up, just pause and yeah, just make sure you get everything right, right? And I'm going to be providing the link to this notebook as well. So just uh, uh, just refer to it if you find anything confusing. Right? Just copy me. So I hope you must have written this. Write it down. You don't need to understand what's going on right now. We're just gonna explain everything bit by bit. Don't worry. So yeah, dls.showbatch is going to show the images that you have over here. So here's just some examples. So this is an example of an Abyssinian cat, a beagle dog, a boxer dog, Staffordshire bull terrier dog, Chihuahua dog, Shiba Inu dog, ragdoll cat. So how do you differentiate between? So these are the names of the breeds of cats and dogs. How do you actually differentiate between what's a cat and a dog? So they also give you some examples. So they have given one particular hint over here. Anything that's a dog will start with a lowercase letter. Anything that's a cat starts with a capital letter. So you see, ragdoll is a cat. Ragdoll starts with capital. Beagle is a dog. B starts small. And now, since I have my data, all I need to do is that I need to feed it inside a classifier. Let me just run a classifier. Mm, Just follow me, please. So here is my data, which is inside this DLs. Here is my model that I'm going to be using, and I'm going to be using a model known as ResNet34. And I need to evaluate my um, model on something, on some metric. I'm going to be using accuracy. So I'm going to be optimizing the accuracy of prediction. Um, I'm going to be writing a few numbers. You don't need to understand what's going on. Please just follow me. Let me run it. So it's going to take about, I don't know, 1 minute about per iteration, and it's going to run for 4 different iterations. So deep learning is an iterative method. You first try to optimize, then you again try to optimize until you reach a satisfying point. So it's going to be running for 4 times, 1 minute each. It's almost going to take about, I don't know, 4 minutes or so. Let's wait. No issues. Right. So I've come across my first iteration, and after my first iteration, my accuracy is 90% or 0.9090%, which is pretty good, and it's going to keep on increasing. I'd recommend not looking at all these other terms: epoch, train loss, variant loss. Just we'll cover them slowly. This is just to give you an idea about like how easy it is to train a model and actually get a model, and you'll see results and you'll be surprised. So meanwhile it's training, I just want to point out a few things about this course. Um, this course is a heavy course. I mean, deep learning itself is a very difficult thing to master or learn in once in like a matter of 4 months or so. So which it means that it requires a lot of commitment from your side. Whenever you do any lab, make sure you spend some time going through it, repeating it unless you're clear with everything. Um, it is a time commitment, and I know you're busy, but it's going to pay off probably. And I can guarantee you that this course is probably one of the best courses in terms of like the modernity of this course, the practical exposure that it's going to give you in all of BITS planning and probably in a lot of colleges in India. And we're working really hard. So yeah, so just so that you guys actually enjoy and learn a lot. We actually get nothing out of it. So yeah, make sure you enjoy the learning process, and it's going to be a lot of fun and it's going to be worthwhile your time. So make sure you just repeat every lab every time. The labs are not very hard, even though they're yeah, it's gonna pay off if you really spend some time on it. I can guarantee you that. Yeah, I think we're just gonna finish our training in less than 30 seconds. Let's see. All right. All right. So I ended up with an accuracy of 93.5% in less than about 4.5 to 5 minutes of training. 6 minutes of training, I'd say, which is wonderful. I mean, 6 minutes is like nothing, and you've trained a world-class model. So why don't we actually see if it works or not? So I'm going to be writing a piece of code that's going to help me to upload a custom image, and it's going to help us, you know, uh, uh, build our own classifier as such. Um, Sorry, it's fastai.vision.widgets. Uh, yeah. Here's I have an upload button which I can press it and I can upload something from a local system. I probably don't have an image of a cat or a dog, so let's just go and look for some cat images on Google. Uh, yeah, so that's a nice cat. Yeah, let me just download it and we'll probably see if it works or not, right? What's the name? I don't know. Cat. Cat. I'm gonna go back over here. I'm gonna say upload. It's gonna open a button. It's gonna open the upload thing over here, and I'm gonna upload this. Right. So I've uploaded my cat image over here, and now I can just simply go. Let's actually see what kind of an image it is. Just follow me. Um, yep, this is the image. And let's actually see what the model actually thinks about it. So the model is gonna predict. Uh, uh, it cannot give you a definite answer. It can only predict based on what it knows best. So let us see what it is. So let's see what is the prediction. So the prediction is Bengal cat. I don't know if it's right or wrong, but it's probably a good answer based on whatever examples I must have provided over here. Or let's actually see because we see things over here. So let's see if ragdoll, if it's gonna predict like this cat is a ragdoll. So let's actually just look at some ragdoll cat. I mean, I don't know if this is a Bengal cat or not. Ragdoll cat. Yep. Let me just save this image. I'm just gonna go and upload an image again. Uh, and I'm just gonna go, yep, see, it works. So the model accurately tells me that it's a ragdoll cat. That's cool. I mean, like just in 6 minutes of time, you have a model that's an intelligent neural network that actually knows what a cat is and what a dog is. Given the fact that we ourselves don't know like how to define an algorithm, a functional code algorithm that can actually describe a cat or a dog, like try doing it. It's a fun exercise. So that's how amazing this is. And there you go. That's your deep learning model in less than 10 minutes with I don't know how many lines of code. One, two, 3, 4, 5, 6, and 7. 7 lines of code, a world-class model. That's amazing. So I'm gonna end this session over here. Why don't you just play around with all of this, and we'll actually start with the first lab on 28th of August. I'm going to be uploading this on YouTube, and you can watch it whenever you can. I'd recommend you watch this at least once if you are not very comfortable with Python and deep learning, or you don't know the idea of deep learning or machine learning. In the end, I'm just going to be leaving some contact details for me about me. So I'm Palash Agrawal. You can mail me anytime at F20. In. I'm also present in the WhatsApp group of this course, so you can just ping me over there as well. I kind of appreciate if you don't send me personal messages all the time. Just send it to me on email, and I'll be very prompt to reply to you. So WhatsApp, and they're on the WhatsApp group as well. I'll just write it as well. And thank you all for if you've reached till this point. I hope a lot of you are at this point. It's a 2.5 hour session, but it's probably worthwhile. So, see you uh, next time. Right, and take care and happy learning.